this video, we are going to learn how to graph exponential functions by hand. The directions say, graph the following functions. Use Desmos to get the table of values. So when I look at this one here, your transformations are your A, H, and K values. So remember, our equation is y equals A times B to the x minus H plus K. A tells you how much you stretch, shrink, or reflect. X minus H tells you how much you go left or right. And K tells you how much you go up or down. So when I look at example 1, I do not have an A value because I do not have a coefficient out here in front of the parentheses. I do have an H value. X minus 2 tells me that this is going right 2 units. And then this minus 1 on the end is telling me that we are going down 1 unit. Your asymptote, this is the line where your curve approaches more and more closely. Your asymptote is always of the form y equals k. Remember, k is that number on the end. So whatever that number on the end is, that is what your asymptote is equal to. Your asymptote is always an equation. So here that's going to be y equals -1. We learned earlier this year that whenever you have y equals a number, that is a horizontal line. So let's graph our asymptote. Our asymptote is at y equals -1. Y equals -1 right here. Asymptotes are not included, so they always are a dashed line. Now that we've written down our transformations and our asymptote, we can go ahead and graph this equation in Desmos to get our table of values and to graph our function here. So I'm going to go ahead and head on over to Desmos. And I want an equation. So I have 1/4 raised to the x minus 2 power. And remember, when you have more than one thing in your exponent, you do need to put it in parentheses. So x minus 2 and then -1. So this is what my graph is going to look like, but we need to copy down the table of values first. So I am going to go to my settings, and then I'm going to go to my table, and I am going to copy down these values. So -2 is at 255. -1 is at 63. This was 15. And then 3 and 0. When you are graphing by hand, you need to be exact. So we want to plot these points. You don't just want to draw a random curve. That is not exact. We need to plot these points. -2, 255. Well, that's way off my graph. That's like up here and out of space someplace. Same thing with -163. So I can't graph these first two because they don't exist on this graph. If I were to extend this graph, then it would. But since it's not there, we're not going to worry about it. 0, 15. I can plot that on this graph. So let me see. That's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So that is going to be right here. And then I have 1, 3, and 2, 0. If I go back to Desmos, I can see it starts up here, and then, oops, I'm starting up here, and it's going to go down from left to right. So my graph looks like this. The asymptote is the curve that your line approaches more and more closely. So as we go from left to right, this curve is getting closer and closer and closer to this asymptote. It will get very, very, very close to your asymptote, but it will not ever cross or touch it. If it helps you, you can graph your asymptote in Desmos. Our asymptote was y equals -1. And we can see here that we're getting very, very close to that asymptote, but we never cross it. So that is your asymptote. The line, your curve approaches more and more closely. Let's go ahead and look at the next one. So on example 2, for my A value, the first thing I see is the negative. The negative out in front tells me that there is a reflection. The next thing I see is the 4. 4 is a number that is greater than 1. So this would also have a vertical stretch by 4. In my exponent, I have x plus 1. That tells me that this graph is going left 1 unit. And then my k value is +3. That tells me that this graph went up 3 units. Your asymptote is always y equals k. So here my k value was 3, so my asymptote is y equals 3. If you just wrote a number here and not an equation, you would lose points. An asymptote is always, always, always an equation. It is always y equals a number. So, when I go to graph this one, let's see. I'm going to go to Desmos. There we go. And I have -4 times 2 raised to the x plus 1 power. Remember, when you have more than one thing in your exponent, to use parentheses, plus 3. So this is what my graph looks like. I'm going to go ahead and go to my table of values. So I have 1, -1, -5, -13, and -29. Now, when you guys see this on your graph, I'll fix this because right now this is not enough space for me. And so I will fix that when it gets to your graph. My asymptote is going to be at y equals 3. So go ahead and make sure you graph that asymptote. For me, that's going to be off my graph. But when you have your graph that is fixed, you will just go to 3. And then I'm going to have -2, +1, -1, -1, 0, -1, 2, 3, 4, 5, negative or +1, -13, so 6, 7, 8, 9, 10, 11, 12, 13. And then negative or +2, -29 is not on my graph. So my graph is going to look something like this. Again, your curve gets very, very close to your asymptote, but it does not cross or touch it. Let's look at example 3. On example 3, your transformations come from your A, H, and K values. For my A value, I see that I have a negative number. That negative tells me that there has been a reflection. The next thing that I see is that my A value is 4. That means that I have a vertical stretch by 4 because that number is greater than 1. And then I do not have an H value, but I do have a K value. Here my K value is -1. So this tells me that this graph went down 1 unit. Your asymptote is always y equals k. In this case, y is -1. So y equals -1 is right here. And then I'm going to go ahead and graph this in Desmos. So I am going to go to Desmos, and I'm going to type this one in. So -4 times 1/4 raised to the power of x minus 1. And so here I can see what my graph looks like. If I go to my table of values, I'm going to copy those down. So I have -65, -17, -5, -2, and -1.25. Again, only worry about graphing the ordered pairs that exist on the graph that you are given. So I have -1, -17. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And then 0, -5. 1, -2. And 2, -1.25. So this graph is going to look like this. Again, we get really, really, really close to our asymptote, but we do not cross or touch it.